Run-of-river hydropower was the main source of power in the British Isles for thousands of years. Small hydropower continues to offer the cheapest, clean, sustainable energy, and the many associate benefits can help manage rivers, reduce pollution, improve fishing and tackle flooding.
There are other advantages to hydropower other than just generating electricity. We report pollutions, we remove all sorts of rubbish from dead animals, dead sheep, rabbits. We remove all sorts of plastic material that would otherwise flow out to sea. This amount of rubbish comes down weekly, monthly, depends, people chuck anything that they don't want, they will throw in the river. We maintain watercourses, we remove dead trees that would cause flooding. Water power was the first type of turbine. It's existed for over 1,000 years in the British Isles. If it was bad, why have fish survived in our rivers? Water turbines do not chop up fish. A healthy fish, if it's swept backwards to the screen, will shoot off up the watercourse again. It's only damaged or unhealthy fish that get stuck on the screen. We have several big power stations on the Severn Estuary. They have cooling water intakes from the Severn Estuary. That's why the power stations are built where they are, because they need vast volumes of water to cool. And on a daily basis, they will take trailer loads of fish from the estuary that get stuck on inlet screens. Whatever the power station is, coal, nuclear, the water after it's been used from cooling is returned to the river and may have risen in temperature by 2 or 3 degrees. That's bad for the ecology of the river. Dry summer flow can become as little as 50 litres a second. Winter flows will enable us to use 700 litres a second, and at times of flood conditions we might get 26,000 litres a second. Our choice of turbine was to try and accommodate this wide range of flows, and when I investigated, the cross-flow turbine as manufactured by Osberger was the best. This turbine has the ability to operate on its design flow down to 1/6 of its design flow, so down to 16%, while still maintaining useful efficiency. Most turbines don't like air introduced into them. The crossflow deliberately introduce a small amount of air into the system. The bearings are in atmosphere, whereas the bearings used to be in water. The side benefit of this is that the crossflow turbine aerates water. At Coley Mill, the quality of our water below the mill and below the turbine was 3 times better than it is above the mill. If the authorities had monitored our site, they would realise that hydropower is actually an advantage in many different ways. The 100 mill sites in the Stroud Valley used to have mill ponds attached to them. We had a vast amount of water storage that would normally flood and accommodate the flood water and cleanse it, and that were all done away with. The crossflow turbine was invented by a famous British engineer called A.G.M. Mitchell, who was a Fellow of the Royal Society in London. Mitchell was a university lecturer in Australia when Osberger, the company of Osberger, approached him and asked if they could make the crossflow turbine.
This is a vertical double-regulated Kaplan turbine made by Osberger. At the moment, we are passing about 2.5 tons of water a second, and that is enough to give us 45 kilowatts of power.
We'd stopped buying coal, we'd stopped buying oil, and we were generating all our own electricity.
In addition to being probably the lowest cost energy from any source, small hydropower can give local industries a competitive advantage. It can fund river maintenance, control and store floodwater, retrieve valuable silt, remove rubbish and plastics from rivers and seas, improve water quality through aeration and the breaking down of toxins from agriculture and industry. Fish abounded in earlier times when many thousands of turbines were operating on our rivers. When will we wake up to all the benefits?
The River Thames has 42 weirs on it. It is of a similar length and a similar gradient to the River Moselle. The River Moselle has hydropower on every weir. The Thames doesn't. Coley Mill is one of 18 mill sites on our stream, and there are over 500 mill sites in Gloucestershire. There are more than 20,000 weirs and watermill sites in the British Isles that we ought to be using for hydropower, and that could be producing the output of a nuclear power station.